Example 3, we want to find the equations of the tangent and the normal to the curve y is equals to x cubed minus 2x squared at the point 1, negative 1. And I'm just going to designate this point as the point P, okay? So at the point P, 1, negative 1. So just taking a look, right? If I've got the cubic x cubed minus 2x squared, I know that we can factorize the x squared out times x minus 2. And I'm doing this because I just want to have a rough idea about what this graph actually looks like and what it actually means when we want to find the tangent and the normal. So the graph of this cubic, right? If I've got y is equals to x squared times x minus 2, the graph is going to look roughly like this, let's say. Okay, take note that obviously graphing this is not necessary, and I'm literally just doing this as digression. Now, if I'm looking for the tangent at the point 1, negative 1, so the tangent is going to be, let's say, here. Okay, so this is going to be the point 1, negative 1. So the tangent is a line which literally just bounces off the graph. Okay, so it's going to look like this. So this is the tangent at the point P, 1, negative 1. So if I want to look for the equation of the tangent, the first thing which I need to do is take the equation of the cubic and differentiate it. So we can see here that dy dx is equals to 3x squared minus 4x. So at the point P, 1, negative 1, if I take x equals to 1 and I substitute it into dy dx, the output represents the gradient of the tangent. So in this particular case, we can say that the gradient of the tangent is equals to 3 times 1 squared minus 4 times 1. And 3 minus 4 is equals to negative 1. And that's going to represent the gradient of the tangent at the point P. So once we've got the gradient of the tangent, and we know that the tangent passes through 1, negative 1, we can straight away say that the equation of the tangent is given by y minus y1 is equals to the gradient times x minus x1. And if I simplify this expression, we've got y plus 1 is equals to negative x plus 1. Of course, if we cancel the 1's out, then we're left with y is equals to negative x as the equation of the tangent. And we can see that on my diagram here, the tangent which I drew is a little bit off because y is equals to negative x obviously have to pass through the origin. But then again, I didn't really sketch this graph to scale or anything like that. It's nothing more than for illustrational purposes, and it's definitely not drawn to scale, right? So that's how we look for the equation of the tangent. So now if I move on to the normal is a line which passes through P but is perpendicular to the tangent. So in this case, let's say that this is the normal I have and it passes through the point P, 1, negative 1. So to start off, we take note that because the normal is perpendicular to the tangent, the gradient of the normal times the gradient of the tangent must give me negative 1. So the gradient of the tangent in this case is negative 1, and what that is telling me is that the gradient of the normal must therefore be equals to positive 1, such that the product of the two gradients is equals to negative 1. So if I know the gradient of the normal, and I know that it passes through 1, negative 1, then now I can say that the equation of the normal is given by y minus y1 is equals to the gradient of 1 times x minus x1. And if I simplify this expression, we've got y plus 1 is equals to x minus 1. And if I rearrange, we're going to end up with the equation y is equals to x minus 2. And this is the equation of the normal to the cubic at the point 1, negative 1. And this concludes example 3.